Here's an example using a half-angle identity to find an exact value of a trig function. I'd like to find the exact value of cosine 5 pi over 8. Well, 5 pi over 8 is not a unit circle value. That's not the one of the ones that's on there. It's not one that we know. But we might recognize that 5 pi over 8 is half of 5 pi over 4, which is a unit circle value. So we can use a half angle identity along with that fact and come up with an exact value. Well, that means cosine 5 pi over 8 is the cosine of this that we just wrote, half of 5 pi over 4. And then I want to remember what's the cosine of a half angle identity. That looks like this. It's a square root, and we have 1 plus cosine theta over 2. And I need either a positive or a negative out here. What determines that? Well, the angle whose cosine we're trying to find determines that. 5 pi over 8 is in quadrant 2, and in quadrant 2, cosine values are negative, so I need the negative. Okay, now to put in our information here. This is minus big square root 1 plus cosine of the thing that it's half of, 5 pi over 4, all over 2. Cosine 5 pi over 4 is one that we know, or we can find easily. So this is 1 in quadrant 3. We got negative root 2 over 2, all over 2. So there it is, but don't leave it like that. We don't want complex fractions, so we're going to simplify. Sometimes that part is worse than the first part, worse than the trig part. So common denominator for the top. And I have, this is 2 minus root 2 over 2 on the top, and then all of that over 2. Well, algebra at work here. Dividing by 2 is the same thing as multiplying by a half. So maybe it's going to look better. Well, it is going to look better. Half of the thing on the top. And then on the bottom, I have 2 times 2, that's 4. The square root of 4, we know that one. It's just 2, so I'll have my 2 minus root 2, the square root of that, over just 2 on the bottom. Whew, made it through the trig, made it through the algebra.